carbon dioxide. First preparation. Carbon dioxide can be prepared by the complete combustion of carbon and carbon containing fuels in excess of air. Okay, so carbon on combustion in excess of air, reaction takes place and carbon dioxide gas is obtained. Okay, next carbon containing fuels like CH4 on reaction with oxygen in presence of excess air, it reacts with oxygen, combustion takes place and form carbon dioxide gas and H2. Okay. Next, laboratory preparation. Laboratory preparation, it can be obtained from calcium carbonate with dilute HCl. Okay. Dilute HCl on reaction with calcium carbonate. Okay. So, calcium carbonate with HCl. Okay. The reaction takes place and form calcium chloride, then carbon dioxide gas and H2. Okay, this reaction takes place. Next, it can be obtained. Next preparation is commercial scale. Okay, commercial scale carbon dioxide can be prepared by heating limestone, that is CaCO3. On heating, it gets converted into calcium oxide and carbon dioxide gas is evolved. So, these are the different methods of preparation. Next, properties. Physical properties. It is colorless, odorless gas and less soluble in water. Okay, colorless and odorless. Okay, less soluble in water. Okay. Next, chemical properties. With water, it forms carbonic acid. Okay. With water, carbon dioxide forms carbonic acid. That is, H2CO3 is obtained. Okay. So, carbonic acid is obtained on reaction with water. Okay. This H2CO3 is a weak dibasic acid. It's a weak dibasic acid. Okay. And it dissociates into two series of salts. Okay. It dissociates into two salts, that is CO3 2 minus carbonates and bicarbonate, that is HCO3 minus. So, carbonic acid is a weak dibasic acid and it dissociates into carbonates and bicarbonates. Okay. So, H2CO3 plus H2O, it forms HCO3 minus plus H3O plus. Okay, so bicarbonates can be obtained. Now, this HCO3 minus plus H2 forms CO3 2 minus. Carbonates can be obtained. So, this reaction takes place with water. So, it produces carbonates and bicarbonates. And H2CO3, HCO3 minus. This is called as buffer system. What is meant by buffer system? Buffer system is a solution that resists the change in pH when acids or bases are added. So, buffer system is a solution. It resists the change in pH when acids or bases are added. Okay. So this solution acts as a buffer system. So the important point here is it helps to maintain the pH of blood. Okay, this buffer system maintains pH of blood between 7.26 to 7.42. Okay, this is the function of this buffer system in blood. Okay. Next property is carbon dioxide is acidic in nature. Carbon dioxide is acidic in nature. So it reacts with alkalis and form metal carbonates. Okay, with alkalis it form metal carbonates. Next, carbon dioxide turns lime water milky. Turns lime water milky, that is CaOH twice plus CO2. Okay, produces calcium carbonate CaCO3 plus H2O. Okay, and this calcium carbonate is insoluble in water, so it forms a milkiness in the solution. So carbon dioxide turns lime water milky, but with excess of carbon dioxide, what happens? This milkiness turns and it forms a clear solution. This is due to the formation of calcium bicarbonate. But calcium bicarbonate is soluble in water. Okay, so due to the formation of this calcium bicarbonate, it gets converted into a clear solution. The reaction will be CaCO3 plus CO2 plus H2O, that is with excess of carbon dioxide. What happens? It gets converted into CaHCO3 twice. This is soluble in water. Next point, carbon dioxide in atmosphere is about 0.03%. Okay, 0.03% by volume is present in carbon dioxide in atmosphere. Okay, this carbon dioxide is removed by the photosynthesis by green plants. Photosynthesis by green plants. They use this carbon dioxide and form carbohydrates. Okay, the reaction will be 6CO2 plus 12H2O in presence of sunlight and chlorophyll. Reaction takes place and it gets converted into carbohydrate C6H12O6. This is carbohydrate is obtained. So green plants use this carbon dioxide for the production of carbohydrates plus 6CO2 plus 6H2. This reaction takes place. So carbon dioxide is removed by green plants from the atmosphere. Okay, but the accumulation of carbon dioxide in atmosphere causes greenhouse effect, which led to the warming up of atmosphere. Okay, as the concentration carbon dioxide in atmosphere is increased, what happens? Causes greenhouse effect. Causes greenhouse effect. So due to this warming up of the atmosphere is taking place. So even though carbon dioxide is not as poisonous as carbon monoxide, increasing the combustion of fuels, fossil fuels, increases the carbon dioxide in the atmosphere, which causes greenhouse effect, and the temperature in the atmosphere is increased. So carbon dioxide, accumulation of carbon dioxide in atmosphere is very dangerous. Okay, which causes the rise in temperature in the atmosphere. Okay. Uses. Uses of carbon dioxide. Solid form of carbon dioxide is called as dry ice. Solid form of carbon dioxide is dry ice. Okay, because it can sublime to the gaseous form without melting. So it's called as dry ice. Dry ice, the uses of dry ice. Dry ice can be used as a refrigerant for ice cream. Dry ice used as refrigerant for ice cream. And frozen food. Okay, refrigerant for ice cream and frozen food. Next, carbon dioxide can be used as a fire extinguisher. It is used as a fire extinguisher. Then, next point, it is used to carbonate soft drinks. Okay. So, gaseous carbon dioxide is used as carbonates for soft drinks. Okay. Next, a substantial amount of carbon dioxide is used for the manufacture of urea. It's used for the manufacture of urea. These are the uses of carbon dioxide. Structure of carbon dioxide. Structure. This carbon, in carbon dioxide, carbon atom is sp hybridized. Carbon atom is sp hybridized. And two sp hybrid orbitals of this carbon atom overlaps with two p orbitals of oxygen atom and form two sigma bonds. Okay, two sigma bonds are obtained by overlapping two sp orbitals, sp hybridized orbitals. Of carbon with two p orbitals of oxygen atom. Okay. And the remaining two electrons in the carbon atom, remaining two electrons form p-pi bonding. P-pi bonding with oxygen atom on two sides. Okay. So the structure will be linear. Structure of carbon dioxide is linear, that is C double bond O double bond O. So this will be the structure of carbon dioxide. Okay. And CO bond length is found to be 115 pm, and in this case the CO bonds are equal and opposite. The CO bonds are equal and opposite, so net dipole is 0. Okay, net dipole is 0. And the resonating structures of carbon dioxide are like this: oxygen, plus, okay, first structure, then C double bond O, then next structure, so this will be the resonating structures of carbon dioxide. Okay.